everyone. Today in the series of theory of computation lectures, we will discuss what is language. Okay. In the previous lecture, we discussed what is symbol, what is string, what is alphabet, and what is string. Right. So I hope you everyone remember the term symbol, and we also discussed what is alphabet, and we were discussing what is string. Right. So you know what is symbol, right? It is a basic building block of TOC, and you can derive the alphabet from the symbols, and it will be represented in the sigma, right? And you can derive strings from the alphabet. The collection of symbols from the alphabet set alphabet is called string, right? So today we'll see what is language, right? So language is a collection of strings, right? So we know what is string. String is a collection of symbols over the set sigma, that is alphabet. Okay, input set. And now language is a collection of strings. Again, if we want to define what is mean by language, right? So now if sigma, that is sigma is the alphabet set, it contains a comma b. A comma b. If the set is containing a comma b, then L1, we are defining the language L1. It is set of all strings of length 2. Set of all strings of length 2. So you have to consider this input set, alphabet, and you have to form the language. From using that alphabet, input alphabet, we are going to form language L1, the set L1. So what are the members of the L1? So they are telling that set of all strings of length 2. That is what L1, right? So now L1, what is L1? Set contains, so the strings would be of the length 2. So length 2 means I have to consider one by one, right? Symbol, I am having the symbol A in the input alphabet. So I can form a string like AA, because AA means the length of the string is 2, right? And BB, I can form BB, right? And then I can make it as AB, just a combination. I'm just combining A and B, and I can write it as BA, right? So other than this, I cannot form anything. So in the previous lecture itself, I have explained what is this. So you have to form a set of all strings with the length of 2, right? So you can have AA, BB, AB, in reverse BA. Okay, other than that, you cannot have one A, one single A, or triple A, or triple B, because the length of the strings would be 2, right? That's why we have only 4 elements, right? This is what L1. And now L2, what is L2? We are defining L2, set of all strings of length 2. Okay, so by considering the input set sigma, we are going to form the language L2. The language L2 set contains the strings with the length 2, length 3, right? So you have to take one by one. You have a symbol called A. So you have to make a string in such a way that the length of the string is length 3, right? So which means I can have three A's. Likewise, I can have 3 B's. Apart from that, I'm going to make a combination, right? So now, how can you form? So just to make a combination, you have two symbols in the input alphabet A comma B. So one is A. So another one is B, and then I'm just going to make it as A, B, A. Okay, just I'm replacing this symbol as A, B, A, and then the first symbol B, A, right? And then I can place B here, so which means A, B. Okay, and then what else may be possible? Here you can make it as A, B. I'm just replacing this B as A, and then in the next string I'm just making this B, A, B. The second B as A. I'm just changing this B as A. Okay, and then I'm just taking third B. I'm just going to alter this symbol B. Okay, last one. So B, A. Apart from that, I have any other? Apart from that, I can able to form any other string either? No, right? I cannot have any other form, right? So which means I'm having 2, 3, 4, 5, 6, 7, 8 elements. Okay, this is the language L2. Okay, set of all strings of length 3. Okay, and now we are defining the language L3. So the language, the set contains set of all strings where each string starts with A. Okay, each string starts with A. Okay, so this is the input alphabet we are considering. So from that set we have to form the string in such a way that the string should be start from A. Okay, so I'm just taking, they have not mentioned any length here, so I can take A as an element, A as a string, right? The string, the what is the condition here, where each string starts with A. The string whichever we are defining, that should start with the A. That's it, that is the uh, condition here. So I'm just taking A as a string. That will be part of the L3, and I can make it as AA, right? Likewise, I can make it as triple A. It goes on. Okay. Apart from that, I can also have AB. I can also have ABB. Okay, and also AAB, triple AB. Likewise, you can have any combination, right? Which means that your string should start with A, but they have not mentioned about the ending or middle string, right? So you can have any combination of A, either A or B. Okay, so which means that the set is infinite set, may contain any kind of combination after A. Okay, so this is what the string. This is what the set of strings. The language is L3, right? So if you notice now, we have three languages, right? L1, L3, L2 and L3. If you notice these three languages, L1 and L2 are the finite set. Okay, finite set. This set contains only 4 elements, and the L2 contains only 8 elements. L3 contains, we cannot define the count, right? Because it is infinite, right? So here we can notice that L1 and L2 are finite set, but L3, when you take L3, it is infinite set, right? It is infinite set. So from here we are concluding that a language written over alphabet sigma can be finite or infinite, right? Both, it can be finite or infinite. Okay, this is what the language in the theory of computation. So just to revise the thing, language is a collection of string. So collection of strings means, so we have defined three languages. From that we are concluding that a language may be finite set or maybe infinite set. Okay. So I hope you understood what is language today, and we'll see uh, powers of sigma. Okay, in the next class. Okay, next session. Okay. Thank you.